Hey everyone, this week we'll be talking about exceptions, and exceptions are incredibly useful in Java as well as other programming languages. So hopefully you get a little bit of a better understanding of what they are from this video, and I'll try and cover again what you're supposed to do in the team assignment and individual assignment as well. So first of all, let's create an exception. Let's do this in my example class. In the playground, let's create an exception. So I'm going to get rid of all of this stuff and all of this stuff, and that was from last week. So now we have this empty class. That's going to be my playground. So let's create an exception. I'm going to create a null pointer exception. That's like one of the most common exceptions you'll find. And a null pointer exception is when I have a reference to an object. And so, for instance, let's create, since we learned about lists, let's create an array list. So this is an object, much like everything in Java is an object. And I'll make it an array list of strings, and I'll call it string list. And you'll notice I didn't initialize it. I'm not assigning it anything. By default, that's going to mean that this variable is the value of this is going to be null. And if you try and do an action on null, so I'm going to take my string list, I'm going to add sample. This will throw an exception. Okay, fine. It needs me to initialize it. There we go. Okay, so now it's even explicit. I'm initializing this string list to null, and then I'm going to try and add something to null. And it's actually throwing a warning because the compiler, I guess, can't. Exceptions aren't compiler exceptions, right? There are two different categories. Compiler exceptions were the ones where if you just type something like random, it's going to throw a compiler exception saying, you can't do this. I won't even try and run your code. But this is saying, I'm going to run your code. The compiler's smart enough to know that there's a warning here that, there's a null. So if I run that, you'll see I get this exception, null pointer exception, and it tells me exactly what line, and it can show me, and that's great. So, my code can throw exceptions, big whoop, right? Well, it's very, very useful because I can deal with these exceptions in a variety of ways, and that's done using the try-catch. So I can wrap whatever I want to code in a try-catch statement. And the try-catch statement requires a parameter in the catch, which is the type of exception you want to catch. So I can catch a null pointer exception, and I have to label it because it's a variable. This is just like calling a function. I'm going to call it, or defining a function rather, I'm going to call it null exception. I should spell that right. And then I can do anything I want with that null exception. I can print out the exception any property on the exception. I have no idea why. Oh, because I need to do a plus sign. Nope. I can get the localized message, the message, I can do a toString, I can get the stack trace. There's a lot of things that you can do on exceptions. Usually, we'll either just print the stack trace on the method or get the message, right? So I can do both. I can do my null exception dot print stack trace, and then I'll also print out my exception here. So if I run this now, my code will actually completely will succeed, right? I won't get an exception. Well, I'll get the exception, I'll catch it appropriately, and then I'll output, well, you know what, I'm actually going to not output the stack trace because apparently printing the stack trace actually prints it to system.error, which is why it's red, so let's make that clearer by not printing the stack trace. And you can see, I'm just going to get the message off the exception, and that message is null. Let's try and see if we can do a toString. That's probably going to have something more useful than the message. And yeah, the toString is that it's a null pointer exception. So you're thinking, that's great, that's not very useful. Well, in this example it isn't, but I could do something like this. I could take in a function, let's create a new method. And let's take an argument, an array list of strings. And I'm just going to call it we'll call it string list again. Okay, so in my method, I can do the exact same thing. I'm just going to copy this down. And then drop this. Okay, so now in my catch, I can do something like I know that the string list is null, so I'll initialize it. Oh yeah, Java 8 doesn't need that. Or maybe it does. No, yeah, it doesn't. Okay, and then I could add sample down here. So now, no matter what is passed in to this parameter, if this string list is null, I can catch the exception, initialize it, and still add my sample string that I wanted to add. So we can try doing that by calling example, passing in null, or no, let's pass in string list so we have a reference. And then I can output the string list. So you'll see I'm setting string list to null. I'm going to pass it in, and this actually might not work, but I'm going to try it out anyways. Yeah. So this is the nature of Java's pass by value. I pass in a reference to string list. I reassign that reference, but this is the local reference because this is passed by value. So I'll actually need to return the array list back. So let's do that. And I deleted the wrong keyword. Okay. So now I can say string list gets example passed in string list. And if we run it, you'll see that the list contains one element, and that element's string is sample. So really useful. Something else that you can also do with string or with try catches is add a finally statement. If I could spell it. And finally is really interesting. This will always run no matter what happens in the try or catch. Right? If there's no exception run, it'll still hit the finally. If there's an exception hit, it'll still hit the finally. So we can see that here, saying I'll do a sys out here saying no exception, and sys out down here saying exception, and then how about I always add the second string to my list. So if we expect the finally block to always run and I pass in null, I would see, let's put sample exception here. I'll see this exception output, and then I'll see the finally will run, and so I'll get the sample exception and the word second in my string list. So let's run that, and you can see the exception was hit. I got the two strings, sample exception and second, in my string list. I add second exception, or sample exception and second. And if I pass in a new array list, so it's not null, when I run this, you'll see I got no exception, I just put sample in my string list, added sample right here on line 30, outputted the word no exception, which you can see happens, and then I get second also added to my list. So finally will always execute. An interesting interview question that always comes up is if you have a return in the catch and a return in your finally, which one will execute? And we don't need this extra return now. And it turns out the finally always gets executed, right? Always, even if there's a return in the catch. You can even put the return right at the very beginning. That finally will always execute, right? So just very interesting to note. Finally always runs. Very, very, I don't know, important to know. Okay, so what can we do with this? Well, your assignment calls for you to create a new package. So let's create a new package. We'll call it exception or exceptions, plural, it doesn't really matter. We're going to create a new class. We're going to call this movement exception. I think it's either map exception or movement exception. I'm going to call mine movement exception. And in this, I'm going to extend the exception class. And then it's going to say I need to, oh, I guess I don't need to implement the constructors. I automatically get them, but the assignment calls for you to implement the constructors. And NetBeans will help you with that. If you insert code, constructor, there's all of these constructors that you'll need, so you can just do that the quick and easy way. And now you have a fully built out exception class. I don't believe you need to do anything more. But again, in Java, right, you could do anything you want in any of these constructors particular to your exception. And then we need to use this exception somewhere else, right? Because this is just the way that the null pointer exception we had in our example. Up here, we had, oh, it's right here. We had this null pointer exception. You can catch any number of exceptions as well. I probably should mention that as well. You can catch the general exception type, which every exception extends. And so you can do something else. If it's a null pointer exception, do something. If it's any other type of exception, do something else. There's also a way to OR exceptions together. The reading talks about that. That's very uncommon, so I'm not going to go over that. So anyways, we have this movement exception. And again, useful because we extend exception. It's a particular type of exception, which means we can catch multiple different types and take the appropriate action as needed. But now we have our exception, we're going to have to use it. Since it's the movement exception, I'm going to use it in my location controller. I have a move north. Some of you might have move to coordinate. I'll have a move north, move east, move south, move west, because that's what I want my player to do. I don't want them to jump to coordinates. But some of you might have that. So however your movement controller works, or your location controller or map controller, you'll have a movement method in there that takes the player and moves them somewhere else. And so in my move north method, I just have it stubbed out, but I can actually move the player north. So I'm going to get the location off the player, and since on my map, I'm just going to again quickly show you how my map is laid out. These are going to be, this is a, if my map is a 3x2, I have 3 rows, or sorry, 2x3, I have 2 rows and 3 columns. And so if I'm moving north, I don't really need to check my column, I only need to check my row. If my row is 0, I can't move north. So I'm going to get the row off my player's location. And if that's 0, then I'm going to throw a new movement exception. And I can use any of those constructors. And in this case, let's use the constructor that takes a message. We'll say player cannot leave map. Right? And this is going to throw, this is not going to let me do this yet because, okay, sorry. So yeah, first of all, I have to make sure I import that. And then it's still going to complain. I still have no idea why. Okay, there we go. So now that it's imported, it's throwing a different exception, or a different problem. And so if you're throwing an exception, you either have to put this in a try-catch saying, hey, you need to either catch this exception, or you need to tell the compiler that this method is going to throw an exception. So we just put this keyword, and we can say this method has the chance to throw a movement exception. And so that's what we're going to do if the player can't move north because they're already at the northmost boundary. Otherwise, we're going to do our standard logic. We're going to say m dot get matrix sub. So we're going to get the player's location, going to get their row, and going to find the row above that, and then we're going to get the player's location, get the column, and we're going to keep them in the same column. And this is going to be the new location. So, and again, it needs me to import that. Okay, so again, the logic is I'm getting the matrix of the map, which is again the two-sided or the two-sided array. Why can I think of the term? The matrix, the array of arrays, and I'm going to get the player's current location, the row of that location. I'm going to take one away from that. That's going to move me up one. So again, in my little map of 2 by 3, 2 rows, 3 columns, if the player is here, their row is going, the player's location's row is 1. So subtracting that's going to move me up here. And then their column is 1, and I want them to stay in column 1. So I got the new location. I'm just going to say set the player's location to the new location, and then I'm going to return true. So that's how I'm going to set up this move north method, and I can do that with all the other different movements as well. So now, in my view, in the turn view, in my move north method, instead of not implementing this yet, I can do, I can call, or I can get my location, or create a new location controller. I can call that move north method, and I will, in another video, explain how to get the player in the map. But for now, I'm just going to pass a null and null, so just deal with that. I could always just create a new player, P here, and pass that in. But just for the purposes of the example, I'm not going to worry about what it is. But you can see the exception here says that this method could throw a movement exception, and I need to catch it, or again, I can put the throws method here. I want to catch it here, so I'm going to try doing this. And I'm going to catch the movement exception ME, and I'm going to output the ME's. It needs me to import this. And for some reason, NetBeans is not importing things the way I want it to. It's probably because my exception package has a capital E. That's not very typical, and I don't know why I did that. But so now I can get the message from the exception and output that, and return. This will return true and cause me to repeat again. So that's how exceptions work. Again, it's really useful because multiple developers can be having their hands in their pot as long as they're, declaring their methods correctly and throwing the right exceptions. Another developer can use that method and know exactly what's going to happen. They're incredibly useful, easy to learn, hopefully, and really good to know. This is just a really basic overview. There's, again, way more complex ways you can use them. But for this class, this is really the way we're going to use them. We're going to create our exceptions. We're going to use them in controllers, make sure the controller methods throw them. And then in the view, we're going to catch them and output messages appropriately and repeat actions appropriately. So for this week's team assignment, together you're going to create an exception. You're going to and the exception type, you should be creating a movement exception and implementing the movement controller. Please, if your movement controller isn't quite built out, try and add more methods to it to get that at least more complete. And then you'll use that exception in the movement controller and then in the view. And then part 2 is catching the number format exception. So a lot of you are reading numbers in from the user, from the input. A lot of you are using scanner.getDouble and scanner.getEnd. Please change that to scanner.nextLine or getNext. I think it's just scanner.nextLine, and then you'll use a static method on double or integer to convert that to a double or an integer, and that can throw the number format exception. So just catch that number format exception somewhere. And then part 3 is just throwing a try catch in your main method, which is that the one that has your main method that kicks everything else off. You'll just throw a try catch in here. So pretty straightforward for the team assignment. Individual assignment is similar to the team assignment. Create an exception, use it in a controller as individuals. Just do that. And then if there are any more classes or views that are reading numbers in from the user, make sure to wrap all of those in a try catch to catch the number format exception. Sorry about the length of this video. It's a lot longer than I usually would, but I kind of rambled. I will post where things start so you can know that. And hope you have a good week this week. Happy Thanksgiving. See the announcement for what's going on with that. And let me know if you have any questions.